Hey class. So today we went over sketching graphs of the form y equals a sine b and y equals a cosine bx. So this combines what we've learned in the past two lessons and just puts them into one problem, right? So instead of simply focusing on the amplitude or focusing on the period, we're doing both in one function. So nothing is going to change about how we treated either the amplitude or the period. We're just simply going to be solving for them simultaneously. Okay, so I had one note before we got into this, and this had to do with just a reminder about what the odd and even properties of these functions allow us to do when we have a negative inside of the function. So if you ever came across a problem, which you should have in your homework, where you had a sine of negative x or sine of negative pi x, instead of evaluating a period to be negative, you want to take the negative sign out and apply that negative to the amplitude, right? So the amplitude here would still be 1 technically, because remember that the amplitude is always going to be a positive value. The absolute value of a is going to equal 1. However, it will change your coordinate points, your 5 quarter points of this function, by making the positives negative and the negatives positive. We talked about inverting about the x-axis. Okay. In cosine, whenever you have a negative, because it is an even function, you can just ignore it. Again, I have to emphasize this with cosine. If you see the negative outside of cosine, such as this example, you can't ignore that negative. That negative is still going to invert this cosine function. It's only when it's inside of the cosine function. Okay, so that was just the side note that I wanted to make before I got into the steps about how to solve these problems. And this is a lot of words, and I could read this to you, but I don't think that would be very beneficial. So I think it would actually be better, since this is kind of like a recording, it's different than being in class, for me to just leave this here for you to read if you'd like, take some notes on it, and then I'll just go through these steps in the next example that I have, okay? So let's just move right into an example. And just to let you know, that is a screenshot from the textbook, so that is also in your textbook. They have some more detailed explanations as well, so feel free to check that out. So here we have something that's fairly easy, and by easy I just mean it doesn't have any negatives. So we don't have to worry about using the odd property of sine or having a negative amplitude. So that is the first step. The first step that they talked about in the 6-step process was to deal with the negatives. So I'll just make a note of that, deal with negatives, but there are none. So we don't have to do step 1. Okay, moving into step 2. So step 2 is going to be to find the amplitude of the function. And in this example, we can see that we have a 3 out front of our sine, and that makes our amplitude equal to 3. We want to also find the range. I can't remember if this is step 3 or not, but let me just double check. No, so it's still, step 2 is technically still the range. Okay, so remember that the range goes from the least number to the highest number of your function. And since our amplitude is 3, that means our range is going to go from -3 to +3. So that is step 2. Step 3 is to solve for our period. So remember that the period formula is P equals 2 pi over B. So this B in this instance is right here, aka the 4 in our problem. So this period is going to be 2 pi over 4, which is simply going to be pi over 2 because we have 2's canceling. Now that we have the period, we want to figure out how our quarter points divide evenly into 4 sections. So this is step 4. And we take our period pi over 2, and we divide that into 4 sections. So that gives us pi over 8. Okay, so the pi over 8, and maybe I should have been graphing this while we were going through these steps. One of these days I'll learn how to draw a straight line. So, sorry, I know I'm going back and forth here, but this is just what we did up here, the 3 and the -3, so the amplitude and range apply to the y-axis, remember that? And then the period tells us that our graph stops at pi over 2. This is where we will make a complete cycle. Okay, so the step 4, this pi over 8, it tells us that each section covers pi over 8 on the x-axis. And let me show you what I mean by that. So we always start with 0, and since each section covers pi over 8 on the x-axis, that means the first point of our quarter points is going to be right here, and it's going to be pi over 8. So remember that when we're splitting into our quarter points, we have one right here, and one right here. It's not exactly even, but it's close. So we need to find the rest of these 2 right here. And you can do this a number of ways, but one way that seems to be the simplest for everyone is just to add pi over 8 however many times you need to get to that spot. And what I mean by that is to get to the second spot, you just add pi over 8 to the first spot. So now we're starting step 5. We do pi over 8 plus pi over 8, which is equal to 2 pi over 8. Sorry, excuse me. Don't know why it does that. So we get 2 pi over 8, which is equal to pi over 4, which will go right here. And then we have our third point, which is going to be adding pi over 8 to this point, or just adding pi over 8 3 times. So our third point is going to be pi over 4 plus pi over 8, which is equal to 3 pi over 8. Okay, so I hope that process was clear. And then the last step is just multiplying our points, our y points by a, and matching our old quarter points to our new quarter points. So before, since we're dealing with sine, right, we started with 0, 0, and that's where we're going to start again, because we still start on 0 on the x-axis, and our y-axis times a is still 0. So that means our first point is going to be here. Our second point, dealing with a sine wave, goes up to 1, but since we have 3 as our amplitude, we're going to go here. The second point of sine goes to 0, so that's going to stay 0. The third point of sine right here goes to -3. Typically it goes to -1, because I'll just start right here. And then the last point is also going to be a 0, so that's not going to change. And this is how we deal with these problems. So you go amplitude. Well, first you go deal with the negatives. Then you find the amplitude and the range. After you find the amplitude and range, you can mark your y-axis. Then after you mark the y-axis, you can start working on the x-axis by finding the period, which tells you the maximum. After you find the period, you can find how big each of these 4 sections are, which in this case is pi over 8. Then you can find the values of each quarter point as far as the x-axis is concerned. And then you can find where your points lie by multiplying the y coordinates by your amplitude. So there we have it. That is an example. And let's move on to, oh yeah, also remember that you can use Desmos in order to solve these problems. And you can always try to backward solve it. Once you have this, you can say, okay, well, how could I have gotten to this point? So that's just something to keep in mind. So example 11 here, we're going to use the same 6-step process to sketch the graph, but this time we have a negative involved. So this one is negative 2 cosine 1/3 of x. And what I want you to try to do actually is solve this on your own by just pausing the video. Then I'll go over the solution in a second. Okay, so this is the solution that you hopefully were able to achieve. The first step, just briefly going over these, the first step in this was to deal with the negatives, but because this negative was outside of the cosine function, we couldn't change anything. We couldn't bring the negative in or get rid of it or anything like that. So I just rewrote it here as the same exact thing, just to emphasize like we can't change anything about this function or the negative in front of it. The absolute value of our number multiplying our function is going to be the amplitude, and in this case, it's going to give us 2, which gives us a range of -2 to 2. And that's what I've plotted here. I've just shown that this tells us what our y-axis is able to be broken down into. Now that we get the amplitude and range, we want to focus on finding the period. And just something to highlight here, when you have a situation where you have a fraction inside of your function, as you can see, this number is bigger than 2 pi. And that's because when you divide by a fraction, remember that this is multiplying by the reciprocal of this fraction. So this is actually 2 pi times 3 over 1, which gives us our 6 pi. And this period tells us the maximum of our x-axis as far as the first cycle goes, which is all we want to map. The next step was to divide this 6 pi into 4 equal sections. So we went ahead and divided 6 pi by 4, which gave us a 3 pi over 2. So this tells us the length of each of these 4 sections. And here I just have the entire x-axis laid out. You get 3 pi over 2, add 3 pi over 2 to get 3 pi, and so on. So now that we have these 2 points, or these 2 axes, we can then define our new points using these. So with the cosine function, you start at your y-intercept of 1 or -1. So in this case, sorry, I shouldn't have said it like that. With the cosine function, you do not start on the origin. That's the main point. So you start wherever you start on the y-axis at the point, whatever this is. So in this case, this is a -2. So we start at 0, -2. And our second point is going to be a 0 of the function, which is this 3 pi over 2, and so on. So notice that because we couldn't deal with the negative, we inverted our cosine function. And then our last step is to connect all these dots, put them all into a graph, and here we have the graph of y equals -2 cosine of 1/3 x. Okay, so let's go over the third and final example. Well, first of all, here's just the Desmos graph of what you get. So the third and final example for this section is this. So y equals -6 sine -pi x over 2. So again, I want you to pause the video, try to solve this on your own, and then I'll go over the solution in a second. And here is our final solution. So hopefully you were able to handle this one. It did have a slight twist on what we've been doing. So the first thing is that we could actually do something with the negative affecting our period. So because sine is an odd function, that means that sine negative x is equivalent to negative sine of x. So all I did here is distribute out this negative, and since there's a negative out here, as we know, negative times negative gives us a positive. So when we rewrite this function, we get a positive value, y equals 6 sine pi over 2x. Okay, and then simply the amplitude is 6, the range is negative 6 to 6. Again, this lets us draw our y-axis. And then the next thing was that we got rid of a pi here. And you might have wondered if that's okay, and it absolutely is. So here we had pi over 2, which the pi's cancel out, and then we multiply by the reciprocal of this, so this is just simply 4. Or to write it out more explicitly, we had 2 pi times 2 divided by pi. So the reciprocal of this is 2 over pi. Pi's cancel out, and 2 times 2 is 4. So once we got the period of 4, we divided it into 4 equal sections, which is just 1. So that means our sections are 1, 2, 3, 4. Now that we have the y and the x-axis mapped out and split correctly, we can then create our 5 quarter points. We have 0, 0 because we are dealing with the sine function, which always starts on the origin. The next point is going to reach its maximum, which is 1, 6, and so on. And then the last step was to map this out, and here we have our sine function. So I hope this helped. This was all we went over on Friday, and as always, let me know if you have any questions. Shoot me an email, and try to get back as fast as I can. Talk to you next time.